Hey everyone, let's look at the last two examples for lecture 15. We're going to continue finding proportions of values below a certain z-score, but this time above a certain z-score. So if we take a look, if you imagine a normal curve, right, where the mean is right here, here we have a z-score of negative 0.34, it's roughly here, and then 1.12, which is roughly here, right? This is the standard normal curve, right? So it looks something like this. And we want to know what proportion of the data is between these two z-scores, right? What is this? So all we have to do is use the chart from our book. We're just going to use it twice. We're going to use it once for 1.12 and then once for negative 0.34. Let's just write that down really quickly. For negative point, remember the negative matters. And then what we're going to do is then subtract. And I'll clarify what that means. In fact, I'll move this over when we get our results, right? So if we go over to Alex, right? Let's go to Alex. And we take a look at our chart right here. So let's do 1.12 first, right? So we have it right here. And I guess we're looking at this value right here, right? 1.12. So that's 0.8686. Okay, and then for negative 0.34, now remember, make sure to do the negative. This matters, right? Negative 0.34 looks like this is the column for 0.04. So we're right here, 0.3669. And then we're going to subtract, okay? So we do 0.8686 minus 0.3669. What's that going to give us? And then this is going to give us, let's see, whatever it is going to end with a 7, and then a 1, and then a 0, and a 5. Yep, 0.5017. Okay, so that's the area, right? The proportion of the population in here is 0.5017. Okay, so that's how you do example 4. The way to do example 5, find the z-score such that 72% of the area underneath the standard curve is between negative z and z. And this is a little tougher, but again, nothing crazy. We just need to think a little bit differently. Right? Now remember, the key thing here is that I guess the mean, which by the way is 0, right? Remember that the curve is symmetric about the mean. I mean, I'm calling this the mean. Really, I guess I could call this 0 right here. Right, I could really call this 0, just to be clear, right? Okay, so we're considering negative z, capital Z, and positive z, capital Z, right? And the goal is that we want the data between them to be 72%, right? That's the assumption that we've been given, right? Well, then I guess that means that the remaining data has to be 28% left over, right? Okay. Well, then I guess that means that this is 14% here and 14% here, right? So I guess that means that right here, it looks like this z-score corresponds to 86% of the data, right? So what we're going to do is if we go over to our chart again, and we just want to look on the chart for whatever says 86%, whatever's closest to that. It looks like this, right? What is that? 0.10 or 1.08? No, yeah, 1.08, right there. So we'll say z-score. Let me just make sure that this is a lowercase z. Z-score, I'll say the z-score 1.08 has roughly 86, or I should say is roughly in the 86th percentile, i.e. is greater than 0.86 of the data. Okay. So now all we need to do is we say, okay, it's 1.08 is right there. So now we're going to consider capital Z equals negative 1.08, right? And let's just confirm that what we say is correct, right? So if we look at negative 1.08, that's this guy right here, right? 0.1401, and sure enough, right? So we check. 0.8599 minus 0.1401 equals approximately 0.72. So capital Z equals 1.08. So we didn't actually even need to do this right here. Right? We could have actually stopped right here and been done. Okay. So that's how you do it using the charts.